Hi, Melody.
Hi.
Okay, I'll start now. Do you remember my lecture from last time? Because, you're the only person, so, it's best if you can just keep your mic on if you want. Okay. And, do you remember my lecture from last time? Hello. Okay, so last time we talked about, arithmetic and geometric sequences, right? And then we talked about, the sum of them. So I might just go over them once again because otherwise there's not really much to talk about. Okay, so again, sequences is just basically like what you guys learned in school, like a list of numbers that have like a pattern. Yeah. And basically, this time we're talking about telescoping and recursive sequences, right? And recursive sequences are just sequences that um, so each term defines is defined from a previous term. Yeah. For example, it's all arithmetic sequences or your normal patterns like 1, 3, 5 and stuff. That's a recursive sequence because it's plus 2 and plus 2 and stuff. Yeah, so you can say an is equal to an minus 1. Yeah. Okay. So, um, last time we talked about arithmetic sequences and how to get the sum of them, right? And we know it's half of a n plus a1, which is some of the first n terms is a n plus a1, which is the nth term plus the first term divided by 2 and then times by n, right? Yeah.
Yeah.
So yeah. So do you wanna do a few examples? Find the sum of 1, 4, 7, all the way to, let's see. Hmm. Let me think. 28. Find the sum of the sequence from 1 to 28. Can you do that for me?
Uh, to 28.
Yeah.
1 plus what is basically 1 plus 28. Um, and then wait,
Hold up.
times 9 divided by 2.
Times. Wait, I feel like I did something wrong. Wait, hold on. Sorry, give me a sec. No, this is wait, this is wrong. It's not half. It's 1 over, it should be the common difference. Yeah. 1 over d. Because otherwise it doesn't work, right? Like, if you think about it, 29 is an odd number and so is 9. And then, so you obviously can't divide that by 2 because that should sum up to be a whole number. But, that's not a whole number. Yeah.
Yeah, but 28 minus 1 is 27, which is a multiple.
Yeah. Because, the common difference is 3, right? So it's so it should be divided by d instead of divided by 2. Yeah.
Wait, what? Divided.
Wait, let me just think. Hold on. Uh, Wait, no. No, it is that because there's there's 10 terms, so it is divided by 2. Wait, sorry, I was just glitching really hard. So there's 10 terms, so it should be like 1 plus 28 times 10 divided by 2, right? Which is 29 times 5. And that's 145. Yeah. Does
Oh,
that
it's
make sense?
not like times 9, it's times 10.
Yeah.
Yeah, yeah.
Yeah. So can you find this? So like this is like a set start and end, right? But can you just find like the sum of the first n odd numbers? So which is like 1, 3, 5, all the way to like 2n minus 1. Can you find the sum to this?
Um, um, 1 plus 2n minus 1 times
Mm-hmm.
um 2n divided by 2.
Well,
No,
what
divided by
made me think
uh
the n?
it's 2n times n divided by 2.
Yeah,
Yeah.
good job. That's why the sum of the first n odd numbers is n squared. Well, it makes sense like geometrically, right? Because you see, like 1 is like that, right? Wait, can you see what I'm drawing?
Yeah.
And then like plus 3 is like that, right? So it's like 2
Yeah.
squared.
Yeah.
And then you add on like another 5, so it's like that.
Yeah.
That's why it's like n squared. Yay. Okay. So then the first n even numbers should be pretty straightforward as well. Just like do those. Like 2, 4, all the way to 2n. Okay?
Yeah. Wait, so it's 2 plus 2n, and then that's divided by um n plus 1, and that whole thing is divided by 2.
Wait, what? Oh, wait, can you say that again? Sorry. Like how you did it. You're muted by the way.
Like the first number is 2, and
Mhm.
then the last number is 2n, so you
Mhm.
plus 2 and 2 are together, and then you times that by the number of numbers in the sequence, which
Which
is
is
n,
mm-hmm.
and then you might divide that whole thing by 2.
Yeah. Which is so it turns into n times n plus 1. Okay. Do you remember geometric sequences from last time?
um kind of like
So what do you know about them?
um
Without looking at the handout, because like yeah.
like instead of adding the same thing each time's the same thing each
Hmm.
time.
So can you give me like an example? A really simple example works.
uh, um
It's not 1, 1, 1, 1.
1 2 4 8
Yeah. Yeah.
16.
So what's like the common ratio for that?
Common ratio is like
for that
2,
sequence. Yeah,
2.
because you multiplied by 2 every time, right? So it's common ratio of 2. And do you remember how like the formula for the sum of the first n terms?
Um, not really.
Okay, do you want to derive it together?
Divide them together.
Derive it together.
Oh,
Like, get the formula together. Okay?
I actually have no idea.
Yeah, I'll help you. You just have to tell me what to do sometimes. Okay, let's call the sum of the first n terms Sn, right?
Yeah.
And that's a1 plus r times. Wait, I'll do a plus a times r plus a times no times r plus a times r to the power 2, and then plus all the way to a. What? Oh wait, oh my god. Does this like make sense so far? Minus 1.
Wait, let me write that out. Cause like, yeah, yeah.
So what's r times small r? Why does it keep autocorrecting? I'll just do the other way. Times r. What's this equal to? Well, okay. Let's write this a different way as well. This is also equal to. Oh, let me just add a1, a1, a1. This is also equal to a1 plus a2 plus all the way to an, right? I mean, no, what did I do? Ah, like this, right? Yeah, sorry. All the way to an, right? Does that make sense?
Yeah. Yeah.
So what's like 2 ways you can write Sn times r?
Like, wait, why is this so small? Like this,
Mm-hmm.
and then plus to an.
Mm-hmm. Well, we want it in like, yeah. That's one of the forms we wanted it, right? But you can also write it in like another form, right? Why is it so big?
R A1 plus RA2 plus everything until
Yeah.
an.
So one of the ways we can write this is oh, I'm just gonna write a1 plus no a1 times plus a1 times r squared, right? And then all the way to this. But it's also equal to. Oh, yeah. But this is like also equal to something else, right? Because, so yeah, this is also equal to a2 plus a3 all the way to an plus 1, right?
Yeah.
Because this turns into a2, this turns into a3, and then this turns into an plus 1. Yeah?
Yeah.
plus a n plus 1. So what can we do now when we have these two?
Um, like you can subtract the first equation from the second one.
Yeah. So we get r minus 1 times. Well, how about you talk me through what we get? Okay.
Um, you get r.
Mm-hmm.
Um, wait, let me see. You get r equals to a1
Well, do we want r or do we want Sn?
Sn.
Yeah. So what do we do now? Okay, just keep talking. Yeah. R equals to
R equals to a1
a1
um um plus where
I'm slightly confused. That's okay, take your time. So you said we wanted to subtract the first one from the second one, right?
wait, so is it like
So
R
what do we get if we subtract this all Sn from Sn times R? What do we let me just move my text box. What do we do? What do we get if we subtract this from this?
the first one from the second one or the second one from first one?
Well, we do second one minus the first one, which is subtracting the first one from the second one. Oh, this is
Uh um
right.
like R equals to a1 minus a times n minus what a1 minus
R
a1
equals to
wait, can I just type it?
yeah.
It's not letting me type. Um it's like that.
Um, I think you got the. First, there's two things. I think firstly you got like the R bit wrong because like okay, if it's Sn times R minus Sn, that wouldn't be just R, right? Because otherwise it would be Sn plus R minus Sn. Secondly,
Oh wait,
I think you got this part wrong as well. Because I think that might be like a misunderstanding. Because like you might think it's the first part minus the second part, but I'm asking for like the second part minus the first part. Do you get what I mean? So you might also want to correct like this part. Oh, and that's also not completely right. Just double check it. It's I like
You told me.
yeah.
wait.
Okay, so
Wait,
No.
this?
wait, are you back?
Yeah.
Okay. the first part's right now because that's right, but the second, you might want to recheck the second part because essentially it's this minus this, right?
Is it like that now?
Got them the wrong way around because it's second part minus first part, not the first part minus second part. Yeah? Because if it was first part minus second part, then it would be this, right? But otherwise, it should be
Oh,
the other way around.
minus the first one. So like, yeah,
Yeah. Do you want to correct that or should I? I'll do it.
like I cannot type on my iPad, so like you can do it.
Time. You can just write it out next time. I'm typing just because I'm on laptop and it's so hard to type. It's so hard to draw.
Oh, okay.
A1, right? But what is this also equal to if you take away this from this? Wait.
0.
Actually, never mind. This should be right. Like, and then, so what do you do from here? What do you do to get Sn from, why did I scribble over? What do you do to get Sn from this equation?
Get Sn from that. You divide r minus 1 from both.
Yeah. So you just divide r minus 1 from both sides, and you should get the answer. Okay?
Isn't it just like, wait, let me,
Just divide by it.
so basically, it just turns into that thing.
Mm-hmm. Well, in this you can like factor out the an as well, right? So this also turns into a1, I mean not an, a1 times rn, r to the power of n minus 1 over r.
Yeah.
Okay?
Yeah.
So now you know how to prove this formula. Okay, let's go into telescoping series. Okay, so telescoping is basically when, like, how should I explain this? It's like each term is like something, like a1 is just equal to something minus something else. Like, let's say a1 is t1 minus t0. Oh, wait. Let me just think. No. No, t0 minus t1. And then a2 is equal to t1 minus t2. So what do you get when you add like a whole bunch of these together? Like this cancels out, right? And then you're left with like the first term because this also cancels out with the next one. So you're just left with one of the first term and one of the last ones. Okay? Does that make sense?
Not really.
Okay. Let me see if I can give an example. Just these are kind of hard to do. Okay, let's use a fraction example. So if you have, where should I write this? So if you have 1 over 1 times 2, what does this turn into? You can turn this into 1 over 1 minus 1 over 2, right?
Yeah.
This makes sense, right?
Yeah.
If you have 1 over 2 times 3, what does this turn into?
1 over 2 minus 1 over 3.
Mm-hmm. Do you want to write the next one?
Wait.
Actually, just write 2 more. Yeah. And then do you want to write we do dot, dot, dot. Do you want to write the nth term? Or like, n minus 1 or n plus 1?
Wait, sorry.
All good. Okay, so what do you get if you add all of these together?
You get 1 over 1 minus n plus 1. Yeah.
Yeah, because this one cancels out with this one. This one cancels out with this one. This one cancels out with this one. And then it goes on, right? This cancels out with like the next here. And then we know this one cancels out with this one. So we're just left with the first one and then the last one. Does that make sense?
Yeah.
So that's basically called telescoping. So basically, I think I basically only seen telescoping with fractions before, but yeah. Okay, do you want to try like a harder one of these problems? So let's think. What about yeah, okay. Can you like use this kind of thinking to try to 1 over 1 times 3 plus 1 over wait, let me just think, does this work? Yeah, it works. 3 times 5 all the way to, let's say, 1 over 11 times 13. Can you do this for me? That looks like a 15. Okay? It's
Yeah.
similar, but it's like quite a lot harder. You might want to like try a few things with it and then see what you can do. Yeah, I think you're getting somewhere. Hmm. Okay, do you want to talk us through this? Like how you got this? Well, after you get the answer. But like, do you want to talk us through it? You're like muted if you are talking, then you're muted.
Like, um,
Yeah.
like, the first one is 1/1 minus 1/3,
Yeah.
and then that equals 2/3, like 2/3.
Mm-hmm.
Um, and then you just divide that by 2 to get 1/3, and then you keep doing that for everything, which is like
Yes.
the
So you've
same.
like noticed that like for every 1 over n times n plus 2, this equals to a half of 1 over n minus 1 over n plus 2, right?
Yeah.
Yeah. So basically for these, you kind of just have to try around and see how you can get like the terms to cancel. And so it's like easy for you to, so it's like easy for you to like calculate the values. Yeah. So what if I told you it was 1 over 1 times 1 plus n, and then the next time is like 1 plus n times 1 plus 2n. That's basically the same thing, right?
Yeah.
And then you just do 1 over n times the first term that gets split and the last term that gets split.
Yeah.
So basically, what I was trying to say before was like, if every term, like, I don't want to use functional notation because you guys kind of haven't learned it yet, but like, um, actually, yeah, I'm just not gonna go into that. Let me see if I can. Okay, maybe I should just go into Fibonacci. Okay, so have you heard about the Fibonacci sequence before in
Is it
school?
like 1, 1, 2, 3,
Yeah, one, one, two, three, and then keep
5,
going.
5,
Five.
8, 1, 1, 2. Wait, I should follow you. Um,
No,
1, 1,
no, I'm not
uh,
writing.
2, 3, 5, 8, 13, 21, 34. Yeah.
So, what's the pattern of this?
Um, like you keep adding the to get like the next number in this sequence, you just like add the two numbers before it.
Yeah. So, for example, 2 is just like 1 plus 1, right? 3 is just 1 plus 2. And then you just keep going. Um, wait, let me. And like a lot of stuff in nature, you might have like what is it called? Like has relationships to Fibonacci. And then there's some like really cool stuff to do with Fibonacci stuff. But I'm not gonna prove it. I'm just gonna um write it out for you. So basically it's like you probably haven't heard of this, but like F F Fibonacci we call this as like the first Fibonacci term, okay? So F1 plus F2 all the way. Oh, I can't type. Just gonna. Okay, so F1 plus F2 plus 2 Fn is equal to Fn plus 2 minus 1. That's pretty cool, right? And then there's also like a whole bunch of other cool stuff, like, yeah?
Yeah.
Did you say something?
Yar. I said yeah.
Yeah, but like before you said something, but it's fine.
Yeah, it's right.
Okay, so, and then this is like the sum of the squares is like f1 squared, oh, squared plus f2 squared all the way to fn squared is equal to fn times, how would you do times? Fn plus 1, which is quite cool. Yes. And yeah. Do you want to just do some random problems now? Because I don't really have much to talk about. Like, as you might be able to tell, I created this quite last minute because I was quite busy this week with like lots of exams and stuff. Yeah.
Sure.
So I created this like last night at like 11 p.m.
That's good.
Okay.
Should I just do like the 3 problems?
We've already done 3, right?
Yeah.
You can do 1 and 2 for now, and I'll try and create some more problems right now, and you can try and do this. Okay?
Okay.
Tell me when you finish the first two questions.
Okay. I think I'm done.
Uh, I think you're basically done, but I'm pretty sure you're just missing something. I think you made a little
I
mistake.
think it's because like in like the question they started like the sequence with 1, which is like 2 to the power of 0, and I just started with 2.
No, but you forgot to bring the two. Oh, wait. Yeah, because, yeah, because it's, because I put it as 1, 2, 4, 8, and stuff. So it started with 1. Yeah, sorry. That
Yeah.
works. Yeah, good job. Um, find the answer. Yeah. Try and do question 3. This might require a bit more brain power and a bit more thinking. But it's basically the same idea as before. You try and split it into two fractions so like you can like link it together, you know?
Wait, I'll just try.
Yeah. Actually just try and find which two fractions you want to split each term into. And then the rest should be very easy.
Yeah. Just thinking.
So what are you thinking right now? Like what do you think it could be split into potentially?
Like I'm kind of confused. So like um yeah.
Okay, this one is a bit harder to think of. But like just tell me what you're thinking right now. Like anything is fine.
Like I'm just like seeing I'm just like timesing this bit together and then seeing if there's a pattern.
Mm-hmm. Yeah. Okay.
G. And then it's basically 1 over 1 minus 2, 1 over 2 minus 1 over 3.
You're thinking that's 1 over 1 minus 1 over 2 minus 1 over 3.
Yeah.
Okay, so you get that's 1 over 2 minus 1. Well, that kind of only really works for the first one, I believe. Yeah, it
Is
only works
so
for the
that
first one.
does the second one not like 1 over
The
2?
second one goes into the negatives. So, I'm not sure. But good like thinking. Okay, see, we don't have that much time left. I might just tell you.
Wait,
So,
like I don't know, like this might not work, but like the first group, um, there's like a six, and then the second group, there's also a six, but there's also four, and then you keep canceling off like that.
mm,
Like
yeah, I guess you can kind of say it like that. That's kind of close, actually. So the first, so if you want the six to be together, then what should you put in? Because you want to link this bit to another, to the second group, right?
yeah,
So these denominators should be the same. So this one and this one should be the same. So what should this be? These two.
um, six.
Six, which is also
1 plus 2 plus 3. Like
uh
2 times 3.
2 times 3, yeah. 2 times 3. Then since this is two numbers together, then what's this one?
Um, um, 1 plus
One
what?
plus
1
one plus
times 2.
well 1 times 2, right? But we realize that this isn't exactly this. We realize that this is double that. So we can just go half of this, right? And then we realize that it works the same for the rest. So we just get, I'm writing over here, if you can see me. So half times 1 over 1 times 2 minus 1 over 2 times 3 plus 1 over 2 times 3. And then you get all the way to like minus 1 over 8 times 9, right?
Yeah.
My hand is cramping from using my laptop. And then all of these middle terms cancel, so you get 1 times 1 over 1 times 2 minus 1 over 8 times 9 divided by 2. Does that make sense?
Yeah.
Okay.
Yeah.
So that's like another telescoping thing. And then, so basically, I saw something really cool. And it's like, do you know how, like, the geometric sequence, like 1 over 2 plus 1 over 4 plus 1 over 8 all the way to like infinity, it gets like infinitely close to like 1, and it's basically just 1. Yeah.
Wait, so like,
One, I mean, it's no, like, if it goes up to infinity, it is just 1, but like, it gets closer and closer to 1, but never gets past 1. Do you know why? Well, yeah. Yeah. Wait, have you seen this before?
Not really.
Okay. So it's just like, let's suppose that this
Wait,
area is one and this is like one times one square, right?
yeah. Oh, sorry.
It's okay. So this area is just one. Okay. So what's this area?
Um, um, 1/2, like half,
Half?
and then a
What's this
quarter.
area? A quarter?
Yeah,
What's this? An eighth?
an eighth, a 16th.
It keeps going, right?
Yeah,
But like you can keep dividing and then but then the squares get smaller and smaller, but like you can always fit another square or rectangle in it, right?
yeah.
So it just like that's why it keeps getting like closer to one as you go up. Yeah?
Why is that like closer to one though? Isn't it closer to zero?
Why would it be closer? No, 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 like the total, the sum.
Oh, the total sum. Yeah, that's close. Then that's closer to
It
one.
gets like closer to one, right?
Yeah.
Yeah. Okay. I honestly don't have much else to say. Can I let you guys go early? Is that loud?
Yeah, I don't know.
Okay. If okay, if you have any questions or have any problems you want me to go over, or just like any random questions related to math in general, then you can just ask me now because I don't have anything to say for the last 5 minutes.
I don't have any questions.
No questions, not even like random school math.
Not really.
Okay. Do okay. If you have any questions, just ask me. And like, yeah. Okay. I think you guys can go. There's only 3 minutes left. Okay. Bye bye.
Bye. Thank
I'll
you.
see you on Monday.
Yeah. See you.
Bye bye.
Bye.